Hey, Joe, how's it going?
Hey, Tony, what's up?
It is good to have you back.
Good to be back, even though you kicked me off for 2 episodes.
I sure did. For those of you listening and watching, because we're doing YouTube this time as well, welcome to the Space But Messier podcast. My name is Tony.
And I'm Joe.
And it's kind of delayed. Sorry about that. We're going to do our best here because of Zoom. But today we're talking about a super cool topic, one that we've been wanting to do for a while. We've just been kind of waiting to kind of learn it ourselves. Neither of us have dived into it. So today we're talking about the multiverse and parallel universes.
It's like my favorite one to research too.
This was
it's
insane.
just crazy.
Okay, yeah. Disclaimer for everyone. It's really complicated, and we're going to do our best to make it not complicated. But by the end of this, I promise you'll be able to converse about parallel universes in the multiverse in any conversation.
Yep.
How's quarantine, Joe? I won't spend too much time on this, but like we haven't really done a podcast since quarantine.
Yeah, it's weird. I'm not a work from home person. I've learned that about myself.
Really?
I need people.
What does that mean?
I'm an extrovert, and being around people really fuels me. But luckily, I have a full house right now, so my sister's in town and stuff, so that helps out. But
whoa,
what about you?
I love working from home. I would prefer, in terms of like professionally, I would prefer to be in the office because I'm a little social butterfly, just like you.
Yes.
But my kids are 1 and 0, so I get to be home with them. This is awesome.
Yeah. That would definitely be a plus. I could see that.
Yeah. Also allows me to be home with Jen because she can do it, but it's still hard taking care of 2 under 2.
Yes.
And Jude still has his colostomy bag, so. But we're doing good.
Yeah.
Okay, I want to throw you off real quick. I tell Joe everything about the episode moving forward, or before the episode starts. So, Joe, what are your top 5 favorite albums? In no particular order.
Okay, that makes it a little easier.
And hurry up, because people don't want to hear about us bantering. They want to hear
that's true. Okay, start from the back. The Head and the Heart title album, great. Freaking like my first probably album that I ever like fell in love with. Amberlin, Never Take Friendship Personal. Coloring Book, Chance the Rapper. Atlas Space, Sleeping at Last.
Gosh, that one's so good.
And then, I mean, when it comes to like how much I listen to it, probably Enneagram by Sleeping at Last. That's a new one.
No, I'm asking your favorite. I don't know. Not what you listen to. Your favorite album.
I think it's probably up there. I can like every single song on that album. I love.
No, that's fine. I'll take it. I just want to make sure you're being, true to yourself here.
Maybe because of the internet, Childish Gambino, possibly. But
that one's good.
Yeah.
Dang. All right. Nice.
All right. Yeah, that's that.
It's fine. Don't ask me what mine are. We can move on. That's fine.
Oh, do you want to? Oh, yeah. What are yours?
No. Nobody wants to hear mine. It's really fine.
I mean, I kind of do though.
But I definitely didn't prepare it. So, let's see. I should have. Obviously, it's not because it's my favorite. It's because it's one of the best albums ever written. Is My Chemical Romance, Black Parade, hands down.
Oh, MCR, dude. Yes.
Oh, good.
Love it.
Boston's first album. Led Zeppelin's first album. Oh, they're so good. They're so good. And I'd have to say Greta Van Fleet's first album as well, because they're basically a modern Led Zeppelin.
Yeah.
And oh dear, what would the 5th one be? I might. Oh gosh, my wife's gonna come shoot me. I'm gonna have to say Recovery by Eminem.
Oh, Eminem. Okay. I like it.
It's so good.
It is really good. I agree.
All right. Well, let's dive in.
Cool. Let's do it.
Okay.
The multiverse.
So consider yourself sitting where you are, listening to this podcast, watching this video, whatever you're doing. Now think, is there a copy of you, a direct clone, watching this video, listening to this podcast, going through what you're going through, waking up, confined to your house, only going out once a week for groceries and wearing a mask because you're sensitive to those who have autoimmune diseases and exposed immune systems. It's a person who is not you but who lives on a planet called Earth with misty mountains, fertile fields, sprawling cities in a solar system with 8 planets. Now, the life of this person has been identical to yours in every respect, but perhaps he or she now decides to stop watching this video or listening, and you decide to continue.
That's crazy, dude.
Like, this phenomenon is just a sliver of what parallel universes cover.
Yeah. And that little excerpt is how Max Tegmark, professor at MIT, begins his paper on the parallel universe in Scientific American, also referring to what many theorize as the multiverse and also the Spider-Verse. I've heard that before too. I think that's
legit. I think that's definitely. What colors would you be if you were in the Spider-Verse?
I like Gwen is pretty badass. But sorry, I don't know. We're a family podcast. I like maybe like the white and red though.
Yeah, the white and red is super cool. Okay, so the multiverse theory as a whole. What is the multiverse? What is a parallel universe? Let's just start at the very beginning.
Yeah.
The multiverse theory states that there may be multiple or even an infinite number of universes, including the one that we consistently experience, that together comprise everything that exists. So people keep theorizing that we have, there's always something else out there. No, the multiverse is saying that that's all that exists. It's the entirety of space, time, matter, energy, all the physical laws and constants that describe them. So like the rate of acceleration that you experience when you fall due to Earth's gravity, like that constant is specific to Earth. And so multiple universes are often referred to as parallel universes because they exist alongside our own in different capacities. Just like that person who's listening.
Yeah.
Different parallel universe.
Yeah. They're there right now. That term was first introduced in 1895 by a psychologist and philosopher and psychologist. A lot of P words. William James. However, this original scientific basis for it began the study of astronomical wildlife, such as black holes and questionable parts of the Big Bang Theory. It really led to so much of our understanding of space, and all that. I mean,
yeah, and we don't. And I didn't include this in my notes or anything like that. But if you want to know, you should do some research on it. It was like literally a period of like 12 years where everyone was like, oh, yeah, quantum mechanics. I forget what that term is called, but where multiple people around the world discover the same thing at the same time without ever coming in contact with each other. A lot of the theories that contribute to multiverse in quantum mechanics happened that way, which is really cool. But for example, on what Joe was talking about, when we learned about these things like quantum mechanics and the Big Bang Theory, it's kind of like in black holes, it's believed that at the very center, there's this like singularity, which is a point that all physical laws cease. So it becomes impossible to predict physical behavior.
Yeah.
Now, I said that that's something that is believed to have happened. So if there's a place where all physical laws cease to exist, then maybe there's a place where physical laws are different. Maybe on the other side of that singularity, maybe not. So, Max Tegmark, this leading investigator, this guy that researched all this, he basically surveyed all these physics theories involving parallel universes. He went through all of them and determined that they form like a 4-level hierarchy of multiverses, allowing for like progressively greater complexity. So we're going to go over these 4. This will explain all of the different types of multiverse theories. And there's only 4. But after this, you'll kind of have an idea of like, oh, that's why when people are talking about multiverses or multiverse theory, they're always talking about something different, or I never understand what they're talking about. It's because there's 4 different kind of versions of it. So
and you'll kind of recognize the ones that you've kind of heard about, because a couple of these are the ones that are most seen in science fiction, Avengers, that kind of stuff. I know we'll get to that, but so starting with the first one, the simplest one, it's just this level 1. A parallel universe is simply a region of space that is too far for us to have even seen yet. So Max Tegmark, he argues that the furthest that we can observe is currently about 42 billion light years, the distance that light has been able to travel since the Big Bang began.
But Joe,
What?
Isn't the universe only 13.8 billion years old? What gives?
Yeah. You know what? Do you want to say it or do you want me to say it?
Say it. No, yeah. That's why I'm like trying to set you up here. It doesn't feel natural. I'm
Oh.
sorry.
He clarifies this. I ruined that segue so bad. He clarifies that the distance is greater than 14 billion light years because cosmic expansion has lengthened the distances.
So,
And I think we talked about cosmic expansion in another episode, right?
we did, but I don't think that we accounted for this. So right now we say that we can only see 13.8 billion light years away.
Yeah.
And we assume that that light was given off 13.8 billion light years ago. But
Right.
what he's saying is that due to cosmic expansion, that in reality, the universe is really what we see is 42 billion light years away because that 13.8 billion light years has been stretched due to the expansion.
Yeah. I would love to see that equation, by the way. That would be awesome.
I have a lot of thoughts about the expansion of the universe. We'll hit it after if we have time. I just tweeted Neil deGrasse Tyson to ask him my question, and he has not gotten back to me. So
that's messed up, dude. He's busy. He's busy. So just finishing up on the level one. So each of the level 1 parallel universes are basically the exact same as ours, and they all started the same.
This one, if I'm not mistaken, the first type is just copies, direct copies.
Just straight up copies. Too far away for us to even.
Yeah, and I think that this allows... I want to dive into this, but none of the words I'm going to say are going to make sense until we go over to the third one. But basically, it still allows for... like when we talk about superposition and how there's more than one option in all the level 1 universes, they're all going to be one option. They're all the same. All the random factors are the same. It's not until level 3 till we get into things that we can change. So that's my bad, Joe.
No.
So
worries.
yeah,
I mean,
as far as
believe
I'm
it or
concerned,
not, for me.
Yeah. No, you're good. Go.
This delay, dude. For me, the simplest type, the level 1, is actually the hardest for me to grasp. I don't know if you agree with that. It's just the weird, like a far off land with like different people or same people, but that the other ones explain better to me, and I'm able to grasp them. So we'll jump into those. But I don't know if it's the same for you. But
yeah, no, I have to say the same. The 2 and 3, 4 is insane, but 2 and 3, I have a pretty good grasp of this. But 1, we read a lot of research papers for this, and none of them clarified if the winds blow a different, like if the winds blow any harder or softer that day.
Yeah.
Or if somebody, decides to turn left instead of right, does that affect it, or is level 1 just straight up copies?
Yeah.
And so we probably should have clarified that, but that's okay. It's not a big deal. It's the way if you look up this level 1, it basically shows copies of our galaxy. Whenever you look up infographics or things like that, it shows direct copies of them. So we're going to attribute it to say that they all started the same and that random factors are the only differences in those.
Yeah.
All right.
You want to jump into 2?
Yeah. So the second one, I know you're just throwing me 2 because I know you want to start 3.
I really want to start 3.
So the second one, and it's a little more complicated. This type of parallel universe emerges from this theory that we were just talking about called cosmological inflation. So it's the idea that our level 1 multiverse, namely like our universe and all the contiguous regions of space, is like one bubble. Okay. And now we're thinking that the second type would be that our multiverse is one bubble embedded in an even vaster and mostly empty volume, but that other bubbles exist out there, disconnected from ours. They accumulate like raindrops in a cloud, you can think. So this is the difference, though. Okay, so they're not just direct copies. So they say that during this accumulation of all these different universes, variations in quantum fields endow each bubble with slightly different properties that distinguish it from other bubbles. Now, I know what you might be saying. This sounds crazy. You sound like a crazy person. You sound like you... Oh, I almost got personal. Never mind. That could have been real bad. This is a theory, everyone, so we are not telling you fact, but these are This is the research behind the theory.
Yeah.
But these, and what I mean by like each bubble has slightly different properties is it's really, really interesting actually to think about how our world would be different if one tiny detail in a law of physics was different. So this second law says, what if we had different dimensions? What if instead of 3 spatial dimensions and 1 time dimensions, what if we had 3 spatial dimensions and 2 time dimensions? What if we had 4 spatial dimensions, 4D everywhere, and 1 time dimension? That's one thought. What if the cosmic microwave background was a little more dense? So this light that was left by the Big Bang, what if that was a little more dense? And they say that somebody actually did the research on this, and if it was not as dense, then the universe would not have been dense enough to form stars at all. So it wouldn't be hot enough to form stars. But if it was more dense than we currently have, then everything would like glob up into these huge, massive galaxies and then just get sucked up by black holes immediately.
Wow.
So, but the question is, we live in this like Goldilocks zone universally. Right. How many other Goldilocks zones are there for different forms of life? Like, like this universe is perfect for, oh wow, I hate myself for not remembering these names. Really? Wow, I feel ashamed.
If I knew where you were going, I would save you, but I'm a little confused.
What are the water bears? The water bears that survived every extinction. How have I not? Tardigrades. Wow. They're tardigrades. I'm sorry, everyone. Tardigrades, the most badass animal ever. They have survived every single, well, they're like more like an organism. Their nickname is water bear. They've survived every single mass extinction, which means that they could pretty much survive in extreme cold and heat temperatures, which means they're pretty much made for this like environment. They can survive on other planets. They'll be able to survive, in different environments. They can survive in the emptiness of space. But what other universes out there exist with different laws? Like, what if every planet was void of all, like, what if the air molecules were so, like, not dense that you could only survive in space and not on a planet?
Wow.
It can get, sci-fi can get pretty crazy in there.
Yeah,
I'm going to write 4 volumes of books, one based in every single level of the multiverse. You'll read 3. Perfect. Somebody already wrote it. It's called Endgame.
Avengers Endgame.
Yeah.
Oh man. Okay. So level 3. This is the one that relies the most on quantum.
Sorry to interrupt. Let's just recap real quick. So number 1 is a direct copy of our universe, just a ton of them out there. Number 2 is copies of our universe, basically, except little minute details in the laws that they function. So tiny little things. Maybe instead of Joe wearing the red Space Messier shirt, he's wearing this awesome mustard colored one. Maybe that.
Yeah.
Okay.
Things would be so different. Yeah.
Things would be so different.
So different. So this is the one that relies most heavily, at least so far, on quantum mechanics. So quantum mechanics predicts that there are a vast number of parallel universes by broadening the concept of somewhere, or elsewhere. So I don't know if we have time for this, but I have some notes that I took from about quantum mechanics that I would love to kind of go over. Do we have time?
Of course we have time. This is
yes.
Jeez. No, the kids are down. Yes. But I do have a pretty ghetto soundboard over here. Like I literally have sound panels here so that I don't wake my kids up because
that's
I really don't want them to. If you guys can't tell by the amount of times I'm rubbing my eyes, it's really late here. It's like 8:30. Okay, that's
a couple hours past bedtime. Yeah,
really late.
So I will try to zoom through some of this.
No, don't zoom. Just do your thing.
Just go.
Yeah.
Okay. Well, first of all, if you think that quantum mechanics does not relate to you, you would be sadly mistaken.
Would I?
You would, because let me tell you why. Today, an estimated 30% of the U.S. gross national product is based on inventions made possible by quantum mechanics. From semiconductors to computer chips to lasers, disc players, Walkmans, all those fun things.
Oh my god.
All that stuff, yeah, came from quantum mechanics. So I think it's such a normal thing to hear that phrase and just, when I was even telling my family and girlfriend about it, they were like, quantum mechanics, dude, like I would never understand it. Leave that to Tony Stark. But it's so much more relevant in our world than we think. So kind of starting at the beginning, we have Schrödinger. This guy,
Erwin, my man.
Erwin Schrödinger. Tony's next cat's name
That's
will
right.
be Erwin Schrödinger.
Mhm. It'll just
So
be
he-
Erwin. I gotta let people guess.
Yeah, Erwin what? I don't know. So he developed the rightfully named Schrödinger equation, and this. So okay, trying to find the best way to word this.
I'm gonna ask you questions during this because I didn't do as
Cool.
much research on Schrödinger as you did.
Cool. So his equation says, and it's hard to grasp, but his equation says that if you stood a card up on its side, right, it would fall both to the right and the left.
Card. Okay.
Um,
Both.
I don't.
Wait.
either.
What?
So it both would fall to the right and to the left. But because okay, this is the wildest part. So he said his equation says that if you were to have a card in a completely vacuumless part of the space and you were to set it down and there was nothing around it, not even a single neuron, not a single nothing, from a neuron from person to photon, nothing.
Okay.
If there was nothing, then it would fall both front and back. That's what his equation says.
So
Now,
okay.
yeah. So what that is it's quantum superposition.
Okay. So
Do-
it doesn't physically fall both. I have to. This is what my daughter does when she wants to watch Spirit, Age of the Cimarron. She goes, horses, both horses. It's crazy.
That's adorable.
Okay, so it doesn't physically fall. It just
Correct.
there's a card, and because it's impossible to know which way it's going to fall, its
Correct.
superposition is both places.
Correct.
Okay,
Yes. Thank you for clarifying that.
that's what I'm here
But so what what he's saying is that just by observing the card, by seeing the card, we are affecting its collapse and controlling which way it falls. Not necessarily choosing which way it falls. But yeah, so it's insane. So literally he's saying that even just a neuron firing in your brain can have enough change in the
particle.
And again,
the particle
particle.
itself firing at the card
yes. So again, this is theoretical.
because it
but
takes it away from 50-50, right? It now
correct. It
Oh.
now has something affecting it.
Okay, I
So
have to
now it
butt
no
in. I know
longer-
you keep going. I
No,
have to
you're
butt
good,
in.
you're good.
You know what this now? The question of if a tree falls in the forest and nobody's there to hear it, will it
Yeah.
make a noise? There's a whole new meaning out of that.
There is. But even that would have, you do have not necessarily neurons, but you have outside environment affecting it. So you
Okay,
have a
so
wind
okay,
or
here we
something.
go. If a tree that's on a perfectly sharp, like somebody chopped it down and it's on a perfectly sharp whittled point in the vacuum of space,
Ooh,
but nobody is there to watch it fall, will it fall?
it falls both.
Oh yeah.
According to Schrodinger's equation,
Cool.
dude. Isn't that the nuttiest thing? And then,
Both.
if you think that's crazy, so this literally leads into the many worlds interpretation. And so what it's saying is, I tried explaining this to my girlfriend last night, and she thought I was a madman, but I will try to do it Schrodinger justice. So superpositions basically create parallel worlds to their inhabitants, staying true to the Schrodinger equation. So I'm going to do another same example. So stand a card on a table, right? You bet. So you bet $5 that it's gonna fall queen side up. Let's say it's a queen. There it is. There's your cell phone. That's the same thing. So you bet money that it's gonna fall face up. So you obviously have, something that you want.
Got skin in the game, baby.
So you got skin in the game. So if it falls face up, then you're happy with the result. But according to Schrodinger's equation, where the card has to fall both ways, there is now also a parallel world where the card fell face down, and you are now disappointed.
So because there is a moment in time where more than one thing could have happened, it creates parallel universe. Okay,
Yes.
What about this? What about I'm about to roll a dice?
I love it.
That's more than two.
Oh, yes. So, I went into this and I didn't. Did I write it down? I don't think I did. There was so much that I learned about. I did not. So with a dice,
It'll create 6, right?
it would create 6. There was something about the fact that it has to be an up or down, according to Schrodinger. There are other theories out there, but according to Schrodinger, it had to basically be a 50 or 50, an up or a down.
Oh,
That
so
kind of thing is the only thing, because it actually is affected by, you have something that's like literally the only thing affecting it is its environment. Does that make sense?
yes.
So according to Schrodinger by himself, he theorized that either up or down, one or two ways. And every time something like that happens, we basically split into having joy, disappointment, or,
So I remember reading too that the reason why it has to split into another universe, it has to, is
yes.
because you cannot anticipate the exact feeling that you're about to feel, that joy or that disappointment. It's impossible for you to understand both of those future potential feelings.
Yeah.
So because in the future you now understand one reality, the other is a separate reality where it's impossible for you to understand it.
Yeah. Yep. It's insane. And
So this is the one that goes through like day-to-day choices. I decide to turn left instead of right. I decide to wear a mask and not wear a mask. I decide to play shoulder hockey in the grocery store.
yeah. Yeah, that would affect that, definitely.
It's happening, people.
It's happening. You're doing it. And so, yeah, so it's just insane. But then Everett came along, and he created his relative state formulation. So what he said is he slightly agreed with Schrodinger, but he didn't think so much of it being a collapse of the postulate, like what Schrodinger said when it's affected by whatever's surrounding it collapses. He was saying that each time that it instead of causing, sorry, get my thoughts together.
No, you're good. You're good.
So I just talked about that many worlds theory. I kind of put these out of order. My apologies. Everett was the one that he spearheaded that. So he theorized that instead of it collapsing down and choosing one side or the other, when the card fell, you enter that second superposition of two entirely different mental states. One where it fell face up and one where it fell face down.
Okay. So the whole thing about knowing if you're going to be disappointed or not, that was Everett.
Yes,
okay.
That was Everett.
Okay.
So you literally, like you said, you can't enter those two different states. So you literally enter different states.
Both of them.
Which still to me, I need more answers, because does that mean that person, do we regroup at some point, or are we now on our own path? Like, that's the kind of stuff that I would like answers to, which, science doesn't have. But around the same time in 1984, I thought this was just a really, really cool thing. So they did an experiment in 1984 called the delayed choice experiment. Have you heard of this?
I actually haven't. Delayed choice experiment?
Yep. So it proved that two of the exact photons can be in two places at the exact same time. I'm sorry. So one photon could be in two places at the exact same time.
How? I'm serious. I have not heard this. This is me legitimately asking.
Yeah. So it literally, they were trying to prove Everett's relative state formulation, and they were able to recreate the same photon in two different places at once. And they haven't been able to go much further than that. We were able to do a cluster of, I think, 60 atoms, maybe? They were able to do a cluster of a little bit bigger. And the next experiment, I think, is supposed to be coming up soon, actually. And they're supposed to be doing it with a virus. So we'll see.
Dear God, why would you do that?
But hopefully they don't do it. Maybe that's where all this came from. They figured out how to do it. Yeah. But just to think about in this world that they are starting to get to the point where they are seeing things in two places at the same time. I mean,
yeah,
it's pretty nutty. And the last point I wanted to go into, and I think is the craziest, I keep saying that, but it's true, is decoherence. So decoherence is the theory of why we can't see these quantum phenomena happening around us, and we can see the classic stuff. So we can see, oh, the card fell, great, I lost $5, whatever.
And to give everyone just a quick, like key terms here, when we talk about classic, when we say the word classic, that means like classical physics. So classical physics is the physics of the big, why the apple falls from the tree, gravity, all of that. Quantum is the physics of the very small. So atoms, photons, electrons, neutrons, things like that.
Yeah.
So we only really see with our eyes things that obey the classical physical laws.
Yeah.
Cool.
So I'm going to read these couple points because it'd be way too hard to try to stop in between them and like explain. And I don't even have all the answers, but it's just interesting to me. So this is taken straight from the report, straight from the scientific report. So this is just
good.
So we'll start with the first point: is a card will fall both left and right in superposition, per Schrodinger. So when you look at the card, the subject of the person and the card interaction extends the superposition to your mental state. So
okay, slow down too.
Yeah. Sorry.
So I can. No, you're good. You're good. I just want to make sure.
So that firing neuron or that photon that flies around and hits the card, that small change is affecting what you're perceiving in that superposition mental state, like Everett said. So it produces a superposition of joy and it produces a superposition of disappointment.
Okay.
And now you're in those two different mental states. So the interaction that we just experienced of that neuron firing and changing that card is imperceivable because the environment around the object and the subject, us, are completely interwoven. So we, everything that's around us, the entire environment, all the atoms, everything, we're interwoven with that. So we can't perceive the change that, man, this is so hard to explain.
Oh, no. It's impossible for us to perceive the change that we alone can commit because there are other factors like interrupting or impeding us. Okay.
Yep. Exactly. Whoa. So, yeah. So just one neuron of our observer's optic nerve would enter a superposition of firing and not firing when you look at the card. So either that neuron fires and it produces that joy if it falls the right way, or it doesn't fire and you're now in that superposition.
We sound like we have a gambling problem talking about feeling joy when a card falls one way. I do have to say I've started to play poker recently just with some friends during the quarantine.
It's pretty fun.
It's pretty fun.
Yeah.
I play on the app.
But to be fair, this is
too pretty fun.
Yeah. This is scientific. This is the examples they gave. So we need to talk to them, not us.
So, sorry, no, I'm interrupting. Go ahead.
No, you're good. I'm just saying all that happens, all that we just explained, the looking at the card, the betting, or not the betting on, but the looking at the card, the firing, and it entering the superposition all takes place within, this is the actual number, 10 to the negative power of 20. No, 10 to the power of negative 20. That's how fast it happens of a second.
10 to the power of negative 20 of a second?
So it's 10
to the power of negative 20 seconds.
Yeah, seconds. Yeah, that's how fast that interaction happens.
What if I just didn't say geez and I said something else? There was a split second where it could have been different.
That's true, dude. Oh man, and now that person, that Tony, is gonna go off and do his own thing.
Gosh. So okay, so let me get this straight. It's impossible to theorize how this interacts with classical physics because, like, this cannot stay in the theoretical realm. I'm sorry, it has to stay in the theoretical realm because as soon as you enter the vacuum into a place where you're able to see this card, that it's impossible for you and a card to both be visible in a vacuum. You have to have light to aid you. You have to have your, car, spaceship, whatever got you there, and all of that will affect you. Light alone for you to be able to see it.
Yep.
So really, it's like Toy Story. It's impossible to see. It's impossible to see the toys awake when you're looking at them, but they only are alive when you're gone. It's self-imposed.
Yes, it's exactly like that. I think Schrödinger actually said that.
I think that Toy Story is just intentional superposition.
Yeah.
Whoa.
Oh wow.
Or no, it's D. What is it called? It's D what?
Decoherence.
Toy Story is intentional decoherence. Yeah. Wow.
Yeah. So yeah, that's that. The decoherence is what explains why we can't see the quantum. I mean, also that it's very tiny, but we can't see the quantum state around us because we can only see one outcome of it. It's just crazy. We can jump back in now, and I went off on a tangent, but I literally was like sitting in my living room researching this last night with my jaw dropped. I would read over the same sentence. The sentence that I just read to you guys, I read over like 18 times. I was like, am I getting that right?
It's crazy because, okay, so we talked about this. We did Intro to Quantum Mechanics episode, I don't know, several months ago. It's a good one. You should go listen to it if you want an intro to it. And we talked about Endgame. I had not seen Endgame at the recording, the time of that recording. But now it all makes sense. So, and I don't do hard spoilers. I'll never spoil something, even if the movie came out in 1900. I don't know if movies were around back then. I won't spoil something. Okay, so what I'm about to say is just standard facts about the movie. Well, they're kind of spoily, but whatever. What's his name? Doctor Strange, right? He can see into time and all that stuff. They ask him what's the possibility of us actually succeeding here? And he basically goes in, he sticks his hand into his little time thing, and he comes out and he says, out of the something million different universes that this happens in, we only succeed in one of them. And that I don't want to say infinite, but the seemingly infinite amount of universes that have been created in the Marvel Universe based on everyone's choices, every human from the beginning of time, out of all of those, we watched the movie in the one universe where they apparently defeated Thanos. Apparently.
That's a really depressing way to look at it, because that means that the 42 other billion.
Yeah, it's super depressing, but how lucky we are that the cameraman just happened to be filming in that universe.
That's just insane, dude. Wow.
We are just we're blessed.
Here we are. We are.
Actually,
yeah.
So that's what we were talking about in Endgame. Gosh, that movie is good.
So good. I know everyone watch it. So that all takes place, but that is the third level of these theories. So this is the one that I just went into, kind of background on that. So what this one predicts is that there's a vast number of parallel universes with broadens the concept of elsewhere. So if you guys seen the movie, you see there's basically a line. There's all these different, based on different choices, there's these different universes branched off of that. Do you remember that from the movie? From Endgame?
From Endgame.
Yeah. So that's basically saying that there's all these different universes located elsewhere, but they're still in the same realm. That makes sense. So in the same abstract realm, they're there, but based on each decision, a new parallel universe has been created. So like you said, so there's millions created out.
So I think that this is saying in our bubble. So we have our top level where it's all of our different universes. And then we have the second level, which is all of our different universes over and over and over again in places with different laws of physics.
Yeah.
And the third level is telling us more instances in which new universes can be created.
Basically in that bubble, yeah, because it's in the same abstract realm. You're not far away. You're not in a different bubble.
I just did a quick search as well, and it turns out that Schrödinger's equation is specifically for two options, but the third level of multiverse will create 6 different universes from a 6-sided die.
Okay, cool. So that's what I was saying. So Schrödinger's was 1 or 2, up or down. Okay.
Yeah.
I was right. I knew things.
There's this, oh man, I wish I could show you my laptop, but it's right here. It's this Venn diagram, right? And in the middle is a little cat's face. And then it says dead up here and alive down here. It's cute. It's cute.
Good.
Okay.
That sounds cute.
So the last one, the fourth and ultimate type of parallel universe, it opens up just the full realm of possibility. So universes can differ not only in location, but also fully in their laws of physics. Now, I wasn't the second one, when I said there's differences, I wasn't talking about the laws of physics. I was talking about
dimensions.
Yeah, mostly dimensions. It's hard because the cosmic microwave background, it does so much for us in terms of the way that our universe functions. It feels kind of like a law of physics in and of itself. The amount of dark matter and dark energy, it feels like laws of physics, but those are just amounts, density, numbers, numbers of dimensions, things like that. This fourth one is literally different laws of physics. So existing outside of space and time, they are almost impossible to visualize. And the best thing we can do is this. So this will be easier for those of you who have taken calculus, multivariable calculus specifically. But let's pretend that we've got a sun and an Earth orbiting the sun. And
cool.
Let's also look at the moon orbiting the Earth, right? So the moon is orbiting the Earth and it's orbiting the sun total. And it looks, when you kind of look at it as an object, it looks like a ring, like a braided ring, right? Because the moon is coming around it. And so because of the laws of orbital mechanics, the laws of planetary motion that we have, our universe can be represented by that shape of orbit. Because for some reason in our universe, gravity pulls everything inward. Therefore, planets are forever falling around their stars, stars are forever falling around their black holes, and so on. But there are other, the circular ring, it's it's but one mathematical structure among just countless others. So Max Tegmark argues that all mathematical structures exist physically as well, that every mathematical structure corresponds to a parallel universe. That level 4 brings closure to this hierarchy. So
Wow.
So that's basically like there are universes that can be explained by the representation of a cone. And wow, I forget all of my mathematical structures, but there are a lot of them. It makes me think of the Tesseract from the end of Interstellar.
I was literally about to say that.
Yeah.
When you finished your sentence, I was gonna say, "Is this
if I'm not
similar to the
mistaken? If I'm not mistaken, that's more of a level 2 where they have different dimensionalities.
Okay. Yeah.
But
That
isn't that
was
okay? So this could mean literally that gravity pushes things apart instead of pulls things together.
Yeah.
Different laws.
It's crazy, dude.
Yeah. So
Oh,
do you
man.
think this exists, Joe?
I do. I really do. I don't see why
Really?
not. I think
I don't.
you
Yeah,
don't.
I bet you believe in aliens too, huh?
You know, why would we be the only lucky ones out here? I think it's far from being understood, but I do think it's something that, I mean, I don't understand it, but I can definitely see how it could be real, and I like to believe in the whimsical and the crazy. So
I hear you on that, and if it was true, I would welcome it.
Yeah.
But why can't things just be one or the other? If something
Yeah.
didn't happen, to me, it doesn't exist. But the
Yeah.
possibility of something existing can continue as like a state of mind, but is that considered a universe? I don't really know.
Yes, yeah, I totally get that. But for me, it's like if I decide not to buy something, then I have buyer's remorse. But is that buyer's remorse that other mental state that I'm like slightly?
See,
It's
that just pisses me off because then there's this kid that grew up who just got everything he wanted in some other reality,
and I got nothing.
I got the perfect amount.
Yeah, there you go. Builds character.
Builds character. I dug a lot of holes when I was a kid.
Oh yeah, dude. Shia LaBeouf. All right.
Dang, that was fun.
Yeah, that was so fun for me. I don't know if anybody will understand it, but I enjoyed it, and that's what this is all about. So
yeah, here's something that we would appreciate. This is our ending spiel, but this is different. This is new for us. For those of you seeing us on YouTube, you're like, oh, Tony's a lot scrawnier in person than I thought. Oh, Joe has a very clean room. Oh, it's really hard to focus on them when they're doing what they're doing. Oh, I don't know. We don't really get a lot of feedback. We have a lot of listeners, which is really great. We love everyone listening, but let us know. Give us a review on iTunes. If this sucks, review us with 1 star. I'll come find you.
Yep.
And leave a comment. Leave a comment on YouTube because we'd love to hear, what you're thinking, what you want, because we don't really have a channel for you guys to tell us what you want, which I'll get to next. But on YouTube, it was funny. There's this video that we have, like Cosmology 101, like what is cosmology? And somebody commented like 6 months ago and was like, you're such an idiot. This is 2 years ago math. And then somebody else commented, hey, idiot, this video came out 2 years ago. And then some lady came in below that and said, hey, like, not in terms of being updated, but I really actually want to know way more about this. Can you do a longer video? It's like, yeah, wow. Totally.
Yeah.
So tell us what you want, what you really, really want. 2,
I'll tell you what I want.
We started Instagram. Space Messier started on Instagram because we started educating people about like all the things in the sky, and there are typically images with all the things in the sky. But it's not as great for sharing space facts and news and things like that. So I will still be doing like Ask Me Anything Space on my Instagram story, so that will not go away. But follow Joe and I on Twitter if you want to stay caught up with the podcast. I'm probably going to be moving a lot of activity there just because it's really easy to keep you guys updated with space current events and this and that. So I'm at Tony DiBernardo. Joe, what are you at?
At Joe Schwal 24, I believe.
Nice. I believe.
Nothing crazy. Maybe just follow Tony and I'll post things on his too.
The last thing I want to say is that I've been thinking a long time about how I've wanted to get news to you guys, because not a lot of you have reached out to me and said that we are your only source of space industry news and happenings and things like that. So I do post them on Instagram, but if it's more convenient for you, I just started a weekly email newsletter. It's really, really simple. It just has the headlines of like 4 current events that week and links to the articles you can read about them. So if you're a headline person, open the email, see that NASA's ventilator got approved. NASA just contracted 4 people to send stuff to the moon. What was the other one? They named the new Mars rover, or the helicopter, they named it Ingenuity. And I think the 4th one was probably something about SpaceX, because why not? So
was it about Elon Musk, baby?
Oh my gosh, we can cover that next time.
Yeah, that's a whole episode.
If you're interested in that, go on my Instagram, go to the link in my account, and you'll see an email newsletter thing. You just click on that and hop in. So, all right, I don't want to take too much away. I guess the last blurb I got is we have a ton of really cool swag. So if you guys want some cool t-shirts, we've got some cool long sleeve ones, these cool NACA old school logo ones. And I don't take a profit on it. I just charge you what the distributor charges, just so more people can have the shirt. So if you want some, they're there for like $15 or something like that.
Sweet.
Cool. Check out the website. All right, guys.
Yeah. And next time you guys play Yahtzee, think about how many universes are created each time you roll those dice.
Oh my gosh, that just gave me so much anxiety. Dear Lord.
So I'll leave you with that.
Whoa. Okay. My next
All right.
band name is
Goodbye, everyone.
Toy Story Decoherence.
I like that. It's almost as good as Mouse Rat.
Oh my gosh. Joe, thanks for joining. I'll see you hopefully next week if we can figure it out. And
yeah, love to.
Thanks, guys. Thanks for listening.
Thanks, everybody. See ya.
Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. That's one small step for man. One giant leap for mankind.
That was definitely an E-ticket.